Hello viewers, in today's session we are going to discuss another important form of indefinite integrals, and in this session we are going to discuss indefinite integrals of this type where the integrand is of the form that is x square plus 1 divided by x raised to 4 plus lambda x square plus 1 dx, where lambda belongs to the set of real numbers, right? So here in this class we are going to solve an example related to this form of the indefinite integral, right? So here we can see that the integrand, it has a numerator and denominator. The numerator is a quadratic function of the form x square plus 1, and here also we have x square plus 1, and the denominator is a biquadratic function that is of the form x raised to 4. Here the degree is 4 plus lambda x square plus 1, and here we have x raised to 4 minus 8x square plus 1. And if we compare these two denominators, we can see that the value of lambda is equal to minus 8, and this is clearly it belongs to the set of real numbers. So here we'll see how we can solve these type of indefinite integrals, right? So let us see how we can find out the value of this indefinite integral. So let us call this integral as I, right? Now the first step to solve these kind of indefinite integrals is to divide the numerator and denominator by x square, right? So we have I is equal to x square plus 1 divided by x square, and here we have x raised to 4 minus 8x square plus 1 divided by x square, and here we have dx. So now the this term, that is x square plus 1 over x square, it can be written as 1 plus 1 over x square, and here we have dx. And now if we take this x square to the denominator of these three terms, we'll get x square, then we have minus 8, and then we have 1 over x square, right? So now this integral I can be written as 1 plus 1 over x square dx, and in the denominator we can collect these two terms, that is x square plus 1 over x square, and here we have minus 8, right? So the first step to solve these kind of indefinite integrals is to divide the numerator and the denominator by x square and get the form of the integral I like this. So now the second step is to make use of the method of substitution, right? So here we'll take a variable t such that this variable t is a function of x, such that the derivative of t with respect to x gives us 1 plus 1 over x square, right? So in these type of integrands, we make use of this substitution, which is quite common, that is t is equal to x minus 1 over x. So here we assume this substitution, that is t is equal to x minus 1 over x, because when we find out the derivative of t with respect to x, then here we have the derivative of x as 1, and the derivative of 1 over x is minus 1 over x square, and this becomes 1 plus 1 over x square. So now a dt can be written as 1 plus 1 over x square, and here we have dx. So now we can replace this quantity with the dt, right? So this is the appropriate substitution here. So now this integral I is equal to integral, and here we have dt. And now let us take care of the denominator. Now in the denominator we have x square plus 1 over x square. So what we will do, we'll take the square of both sides. So here we have t square, and here we have x minus 1 over x square. And here we'll make use of the identity, that is a minus b square, that is a square minus 2ab plus b square. So here t square is now equal to x square, then we have minus 2 ab. So here we have x and 1 over x, and here we have 1 over x square. So this x and this x get cancelled. So we are now left with here we have x square and minus 2, because x and x get cancelled, and here we have 1 over x square. Now taking minus 2 to the left hand side, we can now write t square plus 2 is equal to x square plus 1 over x square. So now in the denominator we can replace x square plus 1 over x square in terms of t, and this is equal to t square plus 2. So here we'll write t square plus 2, and here we have minus 8. So now this integral takes the simple form, that is dt, and here we have t square, and 2 minus 8 is minus 6, right? So now we can rewrite this integral as dt. Here we have t square, and 6 can be written as square of square root of 6, right? And now this is a standard form in indefinite integrals. So now we can easily find out the indefinite integral of this expression, because here we have a direct result, that is integral dx over say x square minus a square, and this is equal to 1 over 2a. And we have the natural log of we have here absolute value of x minus a, and here we have x plus a, right? And here the variable is t. So now we can write the value of integral I as 1 over 2 times square root of 6, because here the value of a is square root of 6, and here we have a log of x minus a, that is t minus square root of 6, and here we have t plus square root of 6, right? And c is the constant of integration. So now let us replace this t by x minus 1 over x, because in the beginning we have assumed that t is equal to x minus 1 over x. So we have I is equal to 1 over 2 times square root of 6, and then we have log. Here t is x minus 1 over x. Here we have minus root 6, and in the denominator we have x minus 1 over x plus square root of 6, and c is the constant of integration. Now simplifying the numerator and denominator, we can now write I is equal to 1 over 2 times square root of 6, and here we have log of x square, and here we have minus 1, and then we have minus x root 6 divided by x, and then here we have x square minus 1, and here we have plus x root 6 over x, right? And Now we can rewrite it as 1 over 2 times square root of 6, and we have log, and this is here x and x get cancelled, so we have x square minus x root 6 minus 1 divided by x square plus x root 6 minus 1, and c is the constant of integration. So now the required value of this integral I is given by I is equal to 1 over 2 root 6, and here this log may be written as ln. Here we can also write the base as e, and here we have x square minus x root 6 minus 1 divided by x square plus x root 6 minus 1, and c is the constant of integration, right? So this is the required value of this integral. Hello viewers, in today's session we are going to discuss another important problem from indefinite integrals, and in this session we are going to evaluate this important indefinite integral where we have integral x square plus 16 divided by x raised to 4 plus 256, and here we observe that the numerator is a quadratic function and the denominator is a biquadratic function. So now let us call this integral as I and our integrand as f of x, that is x square plus 16 divided by x raised to 4 plus 256. Now if we closely look at this integrand, then we can easily make out that this integrand is of the form that is x square plus a divided by x raised to 4 plus a square, where a is 16 and a square, that is 16 square, is 256, right? So we can claim that this integral is of the form that is x square plus a divided by x raised to 4 plus a square dx. So we'll see in this session how we can evaluate integrals of this type. So the first step in evaluation of these type of integrals is to divide the numerator and denominator by x square, right? So now let us divide the numerator and denominator of this integral I by x square. So we can now write I is equal to x square plus 16 divided by x square, and here we have x raised to 4 plus 256 divided by x square, and here we have dx. So now we can write this expression as 1 plus 16 over x square, and in the denominator we can write x square in the denominator of x raised to 4 and 256. So here we get x square, and here we have 256 over x square. Now the second step is to make use of the method of substitution, and here I will make this important substitution, that is t is equal to x minus a over x, right? So this is our substitution where t is a function of x, and here the value of a is 16. So we can now write t is equal to x minus 16 over x. Now differentiating t with respect to x, we have dt over dx, and the derivative of x is 1, and here we have minus 16. The derivative of 1 over x is minus 1 over x square, and that is equal to 1 plus 16 over x square. So now we can write dt is equal to 1 plus 16 over x square dx, right? So now we can replace this expression by dt. Now let us take care of this denominator, and in the denominator we have x square plus 256 over x square, and now our aim is to express this quantity in terms of t. So we'll make use of this equation, and we can take the square of both the sides. So we can now write t square, and here we have x minus 16 over x square. Now taking the help of this identity, that is a minus b square, we have a square minus 2ab plus b square. So here we can now write t square is equal to x square minus 2 times x times 16 over x. And here we have 16 over x square. So we can now write t square is equal to x square minus, here x and x get cancelled. So we are left with 2 times 16 is 32, and this is 16 square is 256 divided by x square. Now taking this term to the left hand side. So taking minus 32 to the left hand side, we can now write t square plus 32 is equal to x square plus 256 over x square, right? So now we can replace this expression with the t square plus 32. So now our integral I takes the form in terms of t. So for this expression we have simply dt, and in the denominator we can write simply t square plus 32. And here we can write dt, and here we have t square, and 32 can be written as the square of 4 root 2, because the square of 4 root 2 is equal to 32. So now our integral I is of this form, that is integral dx over x square plus a square. And here the difference is that we have the variable t, and for a we can write 4 times square root of 2. And this integral is a standard integral in indefinite integrals, and the value is given by 1 over a tan inverse x over a, right? So now this integral I can be written, or it can be expressed using this result. So now the value of this integral I can be written with the help of this result. So we have 1 over a is 4 root 2, then we have tan inverse t over a is 4 root 2, and c is the constant of integration, right? So here this integral has the variable t, that's why here we have the variable t. Now again replacing this t by x minus 16 over x, we can now write 1 over 4 root 2 tan inverse x minus 16 over x divided by 4 root 2, and here c is the constant of integration. So now simplifying this expression, we can finally write the value of this integral I as 1 over 4 root 2 tan inverse, and here x times x is x square. Here we have minus 16 over 4 root 2 x plus c, right? So this is the required value of this integral.